So I thought today we'd start looking at the assembly of this IBM 5150 motherboard clone. We did an unboxing video on it some time ago. This is a faithful reproduction of the, I'm sorry about the glare, the 5150 motherboard. Double-sided board. I've done some high-res scans of it and taken a look. Don't see any manufacturing defects, shorted traces, traces that were etched too far, etc. The board itself looks good. On a board this complex, I think it's always a good idea to take a very good close-up look at the board. In my case, I scanned it on my flatbed scanner at 600 DPI and just took a quick look. There was a couple scratches on it, you know, nothing unexpected. The quality of the board looks excellent. The plate throughs look really good. Overall, you know, I'm very pleased with the board. As you can see, it's just going to be a lot of soldering. Sometimes I really enjoy soldering. Sometimes I find it very tedious. The majority of this project, of course, is soldering. The manual is fairly small. As they say, it's a quote advanced project. You can see there's a number of resistors. Of course, they need to go to the right place. There's a number of capacitors, etc. There seems to be a bit of errata here on a 470 ohm resistor on the board. Tantalum Caps, 0.47 microfarad or 0.047 microfarad ceramic caps. I'm assuming despiking caps. A bit of details on getting the crystal in, etc. Some 47 picofarad caps, of course, go in. Some quick notes on the dip switch settings. So the 5150 is old enough that the BIOS really didn't go out and detect hardware, etc. It relied on dip switches to be set to tell it things like how many floppies, if there was a math coprocessor, how much RAM, and the graphics type adapter to get details on these switches which aren't provided by the team that created the board. You end up going into the IBM 5150 hardware manuals and all those kind of things that kind of pull it out. Again, that's another thing that kind of makes it an advanced project. I have collected a keyboard up that should work with it. I have a vintage power supply similar to this one. I will recap that supply. Before we dive in, some notes. The fact that the blocks go together in the center of the power connector. To get it correct, you could put it on backwards. Some notes on you may have to modify power supply connectors slightly to get them to plug in. I've encountered that before with hardware like this. You know, it's an 8K BIOS. It uses a MC68766 ROM, which is pretty old school, and as they mention here, may not be supported by most programmers. I don't know if mine supports this or not. It comes simply with the anonymous BIOS, so it doesn't have a true IBM BIOS in it. Their notes on the website said the anonymous BIOS had been slightly tweaked to work with the board. I do know they talked about on the design of this board that there was some things that were inaccurate between the hardware reference manuals IBM published and apparently what was on an actual board. So that'll be interesting. The anonymous BIOS welcome screen, pretty simple. I did go ahead and order the diagnostic BIOS option. It's a regular EEPROM with an adapter socket that plugs down in, which basically gives you this landmark Supersoft diagnostic output screen, which should make debugging the board if I have problems difficult. There's the diagnostic ROM in the little adapter board. I would like to at some point get to the point with this where I have a full set of ROMs for it. So I've got the basic and ROM, all that kind of stuff. There's ROM sockets right here. Looks like 5 of them, or 6. Yeah, 6 ROM sockets. And I know that there's a standard BIOS, and then there was the basic and ROM that went into the additional ones. This was produced, I don't know if I can get it in shot here, by MTM Scientific. If you search the web for www.mtmscientific.com, you will find where they're selling this at. It's the PC Retro project. You know, it's not a daunting assembly. It's just attention to detail. If you're going to attempt one of these at your, on your own at some point, I highly recommend, quality tools. I'll be using my JVC soldering station. Does really good work on a board like this. I've assembled a lot of other boards, similar construction to this, with really good luck with it. It's patience and time. So I'll probably shoot a bit of video here of me soldering. I can't imagine anything more boring than watching a soldering video. I watched a soldering video on Mike's Electric Stuff website where he soldered, and I have to say it was not the most exciting video I've ever seen. While I have you as a captive audience here, we'll dive into the bag of parts that came with it and just take a high-level look. There's, of course, a PC speaker. It's the the classic PC speaker. It's even labeled speaker. It is what it is. All the older machines had a similar speaker. There appears to be a bag of resistors here. Yeah, PC Retro Resistor Kit, which is the number of resistors. Like 27 ohm, 9 pieces. That's an interesting value. Those may be for smoothing out signals on address or data lines. 9 pieces of 64K DRAMs. I have a lot of 64K DRAMs in my reclaim boxes, so I'll be able to stuff this up to 256K. Of course, there's the edge connectors. I actually see a damaged pin there a little bit. I'll need to be careful with that. There's actually a couple of them. Well, they're all like that. Oh, I see what that is. That's actually a crimp in the pin to hold the connector in place on the board for soldering, I suspect. Yeah, they all look the same. That's most likely what it is and not damage. There's, of course, a number of these. There's 4 or 5, 1, 2, 3, 5 expansion slots on it. I/O connectors, so the keyboard and cassette. The 5150 actually has cassette I/O. It uses the same cable as a TRS-80 Model 1. I'm assuming from BASIC you can essentially do C-save and C-load. The power connectors, there's a relay, I assume, for the cassette motor. Nothing unexpected there. The capacitor kit, all the caps, most of them are non-polarized. I think there's 3 that are actual lead polarized. I'm not sure. Again, the instructions will kind of give hints through to that. We have the 5th connector for the expansion boards. This is the little ROM adapter that has that diagnostic ROM programmed into it, and a set of sockets to be put in. It doesn't look too daunting until you flip it over and see all of the smaller sockets. Looking at the sockets, they're all double wipe, so they're a little higher quality socket. Double wipe means that you have metal on both sides where the pin goes in, so that there's a contact from the socket to both sides of the pin on the IC. That's much preferable to a cheap single wipe socket where only contacts one side. You get better pressure on a dual wipe socket. This way you get a more gas tight seal against the pin, and that helps reduce corrosion in the long term. I've repaired a lot of gear over the years that used really cheap single wipe sockets when there was lots of pin corrosion. The pin corrosion was down into the socket. The sockets need to be replaced. These look like probably the same sockets I tend to order. I order sockets usually in 100 at a time. I've got a fair supply of solder tail sockets here just for project assembly. There was a period of time where I was assembling lots and lots of S100 stuff as part of the N8 VEM project. Built a fair chunk of the hardware. I've kind of drifted away from that project, lack of time, and somewhat lost interest. I'm sure at some point the S100 stuff will come back into focus for me, and maybe I'll be doing some videos on that hardware. I had a lot of fun with it, and there's a great group of guys out there on the web developing for it. Anyhow, that's kind of off subject here. It should be a fun assembly. We'll see. So I will get set up here to solder, and we'll put a few sockets in. So their assembly instructions, I actually have read them and will follow their directions. They asked to have the IC sockets installed first, and they mentioned there's no socket on U100. And this is why you read the instructions first, because it'd be very easy wherever U100 is to drop a socket in, because it's just another location for a socket. So I need to keep an eye out for U100 and not install it. I normally start with all the lowest profile components first, so the resistors would be where I would typically start. Tend to move on to the sockets for me, then I move on to the decoupling caps, and I kind of work my way up in height, but I'll follow their instructions and start with the IC sockets first. I don't know where on the board U100 is. 73, 92, 94, 96, 99. Interesting. Where is U100? It does say no socket U100. There's certainly U2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. U100 right here. So I'm guessing U100 is completely isolated in this. So if we take a look at U100 here, it's labeled as 200 IP300, this socket right here. None of the pins on the top side of the board are connected. Looking to see if they're actually wired into the power or ground planes. And it looks like they are. This is not unusual on a board like this. There's just an extra chip location there that nothing goes into, and that way if there needed to be some bodging done to make it work, you had a spot to put another dip in, and then you could use bodge wire to connect it in where you needed to. And it's a 1, 2, 3, 4, 5, 6, 7, 8. So it's a 20-pin outline. So you could get anything from a couple of 8-pin devices in here, dips, all the way up to a 20-pin dip. Whatever you needed to do is a bodge. It's unused, so they got the PC board right, apparently on the 5150, at least when they went to production. It's not a bad looking little board. As I get to the capacitors, there's a 0.01 microfarad. This is one of those axle lead caps, and it is polarized. There's 3 of these on the board that are polarized, it looks like. I'll need to keep that in mind when I get to the installation of the capacitors. So anyhow, there's the notes up to this point. Sockets, nothing at U100, so I'll tackle that first. Another quick note on how I normally do this. When I go to sockets, I normally hit the 4 corners of the board first as best I can. So I'll probably be up here. I'll get this on camera. 1 up here in this corner, 1 probably down here, this corner and this corner, and that way when you flip the board over, it's not rocking because there's sockets in the middle. And then I'll just kind of populate my way in. Anyhow, that's an assembly tip from somebody who's assembled a lot of PC boards in his time. So a few other quick notes. I've got, as I said before, some sockets basically at the corners. Make sure the orientation, the notch in the socket matches the orientation in the silk screen. This is blue painter's tape. It's really useful in assembly projects like this. The reason the blue printer's tape is useful is it doesn't leave any residue behind when you peel it off. So I can use this to just tack the sockets down in place. And when I flip the board over, the pins will push on up through the board. And we can solder. So let me get these kind of tacked down. Hopefully I'm tacking them down sufficient. I actually should be tacking all the way across the socket. These may rotate out, but something else to just check quick is that all the pins are actually through, which they are. I can see them and feel them. Bring over the soldering station. Where is the tip cleaner? In the mess I call a bench, my tip cleaner has vanished. That's entertaining. So I've gone through and soldered up the initial sockets that you saw me put on, these 5. A couple of things I didn't mention before. One of the reasons that I tack just the corner pins first and then check is to make sure it's in flush, and also I have many times put a 14-pin socket in a position for a 16-pin socket. You know, I've got the wrong socket and don't realize it. And if you just dive in and start soldering pins, you all of a sudden get oh crap, it's the wrong size socket. They're a bear to get back out without damaging the board. Typically I have to cut the socket up, which is also dangerous. So one of the reasons to do the corners, as I said, is just to make sure I've got the right size socket in. I also like to work then from the largest sockets to the smallest. So I would start with the 40-pin guys and kind of work my down 28 and 24s. And then 16s. You know, you can't put a 16-pin socket into a 14-pin layout. So by working from biggest to smallest, it also helps limit getting the wrong size socket down into the board. You know, I've done it several times over the years. You know, you just get into a rhythm when you're chugging along and you just miss it. So that's useful. Another thing, obviously, is sufficient light. I've got natural light through the window behind me, and then my my LED shop lights above, which is of course is what's causing that glare there. And I'm also, for me, wearing some reading glasses with a bit of magnification so I can, you know, see really well. You know, setting yourself up properly, decent tools, decent lighting, a process that helps guide you away from making mistakes is always nice. So hopefully 1 or 2 of those tips are useful. The 4 40-pin sockets are in place. A bit of painter's tape to hold them in place, a bit of downward pressure on the board, and tack the corners. Same process you watched before. I'll then make sure the sockets are in level and flush, and we'll finish soldering up all the additional pins. These are up here. It's just meticulous work. Attention to detail helps, as it does with anything in electronics. I'm not going to take you through soldering all of these. That would be very tedious, I would think. But give you some examples here. Those look flush. Just another quick comment while it's fresh in my mind. In the outlines, you can of course see the part number 74LS or S373 and L670, etc. There's a resistor pack that goes there. When you get these smaller sockets in, sometimes you can see through the little opening to read the part number below, sometimes you can't. I mention this because it's another reason I took those high resolution scans of the board, is then I can read the silkscreen very cleanly and easily, and if there's confusion about what part goes where, I can reference back to it. So that adds the 28 pin, all the 24 pin sockets. I'll do a quick visual, making the effort to look at every last one of the solder joints to make sure I didn't miss one. I see one there I'm not completely happy with. It's better. I'm really looking for a couple of things. The shape of the solder connection. It should, the board I've always used is shaped like a little tiny volcano. I see one more joint there that might actually be bridged. It is bridged. Little solder whisker between the two pins there. I guess that's another tip, is a few sockets, solder, visually inspect. A few more sockets. Don't try to stuff the board at once. It's too easy to miss a solder joint when you've just got a complete sea of them to do. One of the most difficult troubleshooting things I ever ran into with a board I assembled was a single missed solder joint. That the board was intermittent. Work didn't, work didn't, work didn't, and it went on and on and on. And I finally actually got out some higher magnification and looked at every solder joint, and bing, there it was. If I'd have done that up front, been a bit more disciplined, I probably could have avoided lots of debug time. You probably also heard here in the background, I have a fume extractor. It's a Hayco 493. It was a gift from my son for my birthday quite some time ago. When I remember, I pull it out and use it. There's enough solder joints here that using it's a good idea as best I can. It does an okay job. It doesn't get everything. I still get smoke in the face, but that's part of the charm of the hobby. So I've moved on to the 20 pin sockets. Remember that U100 here didn't take a socket per their notes. The 20 pins are, of course, this group here. There was the exact number of 20 pin sockets they provided with, again, the slots I found for them on the PCB. So when the counts match like that, it's nice because it gives me some confidence I got them in the right places. Let's tape the seed of these down. Assuming I can get the tape to rip. Well, that didn't rip very nice. Add a little extra here. And same process I described before. I will tack all the corners, visually inspect, make sure they're flush, and solder the pins. And there's been additional progress made. 20 pin sockets are all soldered in. I've inspected each one of the solder joints, touched up a couple of them. I'm actually going to take a break at this point. This gets rather tedious. And I'll come back and tackle some more of them. But anyhow, I don't know how long I've been soldering here, an hour, maybe. Maybe not that long, maybe longer, I really don't know. But anyhow, there is where things are at this point. And we'll pick up later. So all the sockets are soldered in. Only made one mistake, put a socket where this dip switch goes. Had to remove it. Bit concerned that there's two sockets left over. Maybe they're just spares. If they were both 16 pin, it would make more sense. They were meant for the dip switches. But one of them is an 18 pin, which leaves me thinking about a 16 pin socket, perhaps in an 18 pin dip position, but I don't see that anyplace on the board. So I just think there's just a couple of extra sockets. Further instructions, we move on to the resistors next. And we have our little bag of resistors. And I'm sure it's exactly that, full of resistors. So I am going to go through these resistors and measure them all. Label the little tags to make it easier to sort them out and install them. So I've started to mount resistors. I've got the first 5 in. I'm using a lead forming tool to get them pretty consistent. R10 here is actually a half watt resistor. Took a second to realize that until I looked. The leads are bent through. I'll go ahead and solder these guys up. Of course, it takes lots of shuffling to get the proper glasses on and get the soldering pencil and everything. I know, complain. at half watt. Takes a little bit more heat. One of those took solder well. I think this tip is getting near its end of life. It's been used a lot. Anyhow, there's 5 resistors soldered up. I won't bore you with the rest of them. So the resistors have all been measured, leads formed and installed. There's a sea of resistors around. It took a bit for me to locate R20 here. I just couldn't see it. And there's actually one up here labeled TD2 that actually takes a resistor, and that was notes that they had. Capacitors, there's these tantalum caps. Tantalum caps are polarized, and I find this rather interesting. See if we can get focus on this guy, maybe. He's got, I almost lost him. He's got 3 leads. He's a little tantalum cap. Now here, we're not going to get good focus here. It's a little tantalum capacitor, 10 microfarad, and it's got 3 leads. And according to the notes, they did this because since it's polarized, it can be put in either direction without an issue. If you put a tantalum cap in backwards and power it up, they tend to pop really loud as they come apart. So I've never seen a 3-lead tantalum cap before, so that's something new. Well, after a couple of more hours of soldering, we've got the board to this point. I think actually all the soldering on it's done. A lot of sockets, handful of caps. There's the back side for what it is. It'd help if I could hold it in frame. So I see cassette keyboard, I believe, power, of course the dip switches, speaker over here. Configuration jumpers, dip switches, of course, for configuration. So really the next step on this is to do some quick ohm checks on it just to make sure there's no shorts on the power rails. I'll then check out the power supply and start thinking about trying to bring this thing up.